I'm a teacher Limboka Sajuga Masame. Let us have a look on the question below. You have asked to draw the diagram of a single pulley system with velocity ratio of 6. Okay. Velocity ratio, we know that is equal to number of pulley, which is equal to 6. How we can justify this relationship? Let us first consider the definitions of velocity ratio. That is equal to effort distance divided by load distance. We are assigning these letters in order to explain this relationship by using the diagrams of a single string pulley system that has got a 6 pulley. The 3 pulleys forming the fixed system, while the 3 pulleys at its bottom downward are forming the movable system. Now we have a fixed system at the upper part and a free movable system at lower part. Now, and this end is where effort is applied. When a one applies effort to a distance PQ, then the motions of the strings will be from Q to P. At the same time, the pulley number 3 will move upward to a distance Y, which is we call it is the load distance. And hence this position Q will find itself at the positions of pulley 2. Then in order to understand this movement very well, as we assign the letter Q, P, R, S, and T, let us consider the sections of this lower end here. Okay, our vertical position of the strings as a P, R, S, T as usual, as we assigned from here, P, R, S, T. But for motions of the effort, then the motion of the strings will be in such a way that the position Q will be at the bottoms of this lower pulley, while the position P is moving up and taking the position of the origins S, while Q takes the position of the R, and this R takes the positions of T. Hence the strings will be moving a distance which is twice the distance of the effort. We assign the distance of the effort as the distance of the strings because effort applied in the strings, and then the distance now is twice the distance of a single strings, which it is twice the distance of effort. While the load, this pulley number 3 move a vertical distance Y, which is equal to the distance of the load, which is also equal in magnitude with the distance of the effort the strings takes to move. Now, when we have a 3 pulley, we must times this distance by 3 for total distance moved by strings for a single movement of effort. The single movement of effort. Now, we will have 6 distance of effort, and here we will have 1 distance of effort or distance of load. Now, from our relations, at the end we'll find that 6 x sub e divided by xl, which is equal to xe. Then xe and xe is cancelled out. Then we remain with 6 values. This is equal to velocity ratio. Hence, we have proven that velocity ratio is equal to the number of the pulley. Okay, let us see how we can find the another part. We've asked to find efficiency of this pulley if we've given 1,000 newtons and 4,500 newton load. Then the effort here now is 1,000, and our load is 500,000 newton. Now, from definitions of efficiency of machine, that is equal to mechanical advantage divided by velocity ratio, then we substitute the expressions for mechanical advantage, which is load divided by effort. Then we substitute the value for load and effort and the velocity ratio. We get 75%. this is the efficiency of this machine. This is the ability of doing work for this machine, this pulley system. Now the other part, we've asked it to find the energy wasted in order to move the mass of a 5 kilogram through a distance of 2 meters. Now we know that the distance of this mass of this load is 2 meters, and this load is equal to 5,000 newtons. Now we must find first the effort that required to raise this 5,000 newtons weight of for a particular object. This object is another object that moved a distance of 2 meters. This energy waste, we must first find the effort by using relationship of efficiency. We know that this is very same machine is got the fixed efficiency for any load that will be used, that will be moved or lifted from one position to another position. Now we substitute the value of velocity ratio as it is constant, as equal to number of pulley. Then the effort, we must find it by making the subject in terms of the load, and the velocity ratio and the efficiency of the machine. Then we times with 100%, so that percent and percentage cancel out, and our effort is equal to 1111 newtons. In order to find the energy waste, we must refer this relationship for tensions or for effort. For tensions of effort for a single pulley, that will be equal to the energy wasted as a friction force when the energy wasted as a weight of a single pulley plus a load that is lifted. Now our effort, we multiply it with distance moved for such effort when we consider for a single pulley. Then when we consider for a total pulley, then we must sum it with the distance covered. Then we must also find the energy wasted by taking the independent friction times the sum of the distance plus a weight of the pulley times the sum of each distance that covered. And remember that this weight is equal to the sum is equal to the weight of all pulleys, and we assume that all pulleys almost have the same mass, and then we multiply each with distance moved along in order to get the work done. Then we plus the work done on the load by taking the load distance times the load itself. Now for a clear explanation for energy wasted as for frictions and for weight of the pulley, then we must take a friction force times the sum of the distance covered. As you can see here, the sum of the distance covered is equal to the strings that is moving from point Q to point P is strings that cause the frictions under the surface of this pulley. Hence the distance x is what produces the frictions, and the distance x times the friction force is what we said we work done against the frictions, and the distance from here to these lower positions is what we call the distance moved by a single pulley. And when we multiply with the weight of the single pulley, we have work done against the weight of the pulley. Now we assume our reference for positions is that is the tangent of the pulley, and we may assume also by this position is at the center of the pulley. That's your wish. When you put it at the center or at the tangent of the pulley, the result will be the same, very same. Then this frictions and this weight, the sum of these energies, it is equal to that of the three individual pulley. Then when we substitute the values at the end, we get the energy wasted is equal to 3,333.32 Newton meter. Then our answer is as you can see below. But something to note is that the distance xe is the distance for a friction, while is equal to the distance for a load, is equal to distance xt. Now, and distance for E40, when it comes to the expressions here, it is 12 because we have 3 pulley. Then the sum for 3 pulleys must take 2 times a single distance, which is 2 meters. Then you multiply with 3 pulleys. Distance for the strings for the 3 pulleys is equal to 12 now, and minus with 5,000 Newton times the distance for the load is just x for the load, which is just times with a 2 meter. Then 10,000 for 333,000.32. Then when we minus, we arrive into the answer here below. That is something to note here below. We shall pass through it and understanding it, how we apply to these parts. Just we try to show how energy loss is happening in a pulley system. Please like and share. Don't forget to subscribe for more videos like this one. Thank you.